Alright, so let's do the paper problems for this week. First up, exercise 4.2. We have something a little bit weird here. We're trying to tell a story and draw some indifference curves that don't really look like regular indifference curves, so we kind of understand how indifference curves work. Okay, so first we have the wife, and she likes both grits and cereal, but averages are worse than extremes. So this is not usually the case, but we're just putting this assumption on to help us understand what this would do to indifference curves. Okay, so first we need to put grits on the horizontal and cereal on the vertical. So I have grits and cereal. And the other interesting thing is that averages are worse than extremes. So this is the opposite of the convexity assumption. Now if you recall, the convexity assumption makes our indifference curves curve like this. So the opposite of the convexity assumption is going to make the curves look sort of like this. Okay? And she still likes both of them, so as she gets more, 1, 2, 3, of either of them, her happiness level is going to go up. 1, 2, 3, but it's just that they're shaped the weird way, because look, if you connect the line, remember a line that connects any two of the extremes is a convex combination or an average of the two, you'll see that this line is under or worse than the other indifference curve. Alright, next, suppose we ignore the labels, alright, and could we make my indifference curve, my indifference map look the same as my wife's? Now recall, I hate cereal and grits. That's from the previous problem, 4.1. And yeah, actually, if you recall, if you hate both of them, then you're getting less happy this way. So actually we would just label them this way, where 3 is higher. So you're increasing in your level of happiness as you get closer to the origin. Now the question is, are my tastes convex? Well, yes, actually. So now look at this. If I connect any two points, and the line that connects the 2 points is actually lying, so since we're looking at it backwards, this is actually better than the endpoints, and that does satisfy my assumption of convexity. Okay, now let's look at this mathematically. Suppose that we represent this with a utility function that looks like x1 squared plus 4x2 squared. Okay, could this utility function represent the tastes I graphed in part A above? So this is actually the part where I am increasing in happiness as I go out, except that the convexity assumption is violated. It's a non-convex set. Okay, in order to do that, let's examine the marginal rate of substitution. Look, for all of these, the marginal rate of substitution starts close to 0, and then it starts getting steeper and steeper. The marginal rate of substitution, don't forget, is just the slope of the indifference curve. Let's calculate the marginal rate of substitution. So the MRS is equal to negative partial u partial x1 over partial u partial x2. That's equal to partial u partial x1. Let's take the partial derivative of this with respect to x1. So first is, just bring this down, that's 2x1. And what's the derivative here with respect to x1? It's 0. So it's actually, remember that the derivative of a sum is just the sum of the two individual derivatives. So this is 2x1 and this goes to 0. So it's just 2x1 plus 0. I'm going to leave the 0 off. Partial u partial x2. Let's do the exact same thing, but with respect to x2. So again, the derivative of this side now is 0. So it's going to be 0 plus whatever the derivative of this side is. I bring the 2 down, it's 8x2. Okay, and that is equal to, well, there's a negative out here in front, negative x1 over 4x2. Let's ask this question. If I'm way over here, where I have hardly any x1, so my x1 is small and my x2 number is big. So put a small number in here and put a big number in here, small over big, and that's going to make it be pretty small or flat, close to 0. Let's move it over here. Let's see what happens when I have a lot of x1 but almost no x2. So put a big number in for x1 and a small number in for x2. You'll see that this becomes a big negative number. So it's pretty small, close to 0 over here. It's big over here. Yes, this MRS clearly increases as I move this direction in the quadrant, and it clearly can represent these tastes for the wife. All right? And finally, the last question, how can you transform the utility function to be consistent with my tastes? Oh, okay, so we already know this general function can work for this general shape. But what furthermore do we know? I know that, for me, I hate this stuff, so the more I get, the less happy I get. In other words, what I want to do is I want to make a function that's basically the same, but gets to be a lower number, or it takes away from my happiness if I get more of the stuff, and that's easy. So let's call this u prime of x1 comma x2, and that's just going to equal negative x1 squared minus 4x2 squared. Notice all I did was multiply this by a negative number. Why? Because, well, the simple way to think about it, now if I get either more x1 or more x2, my utility goes down, and I get less happy. I'll leave it to you to try this. Go ahead and take the MRS of this function, and you'll see it turns out to be the exact same. All right, let's do exercise 4.6. Okay, so basically we're going to take the idea of an indifference curve or utility function and use it for movie ratings. It's essentially the same thing. It's the happiness after seeing a movie. All right, so suppose we go to see Terminator 2 and Emma, and so let's see, I rate Terminator as an 8 and Emma as a 5. The wife rates Terminator as a 5 and Emma as a 4. Okay, the first question. Do my wife and I agree on which movie is better? Well, yes. If you look, both of these rank Terminator, 8.5, higher than Emma, 5 and 4. How would your answer change if my wife's ratings had been reversed? So if my wife rated them 5 and 4 versus 4, or 4 and 5 versus 5 and 4, now suddenly she likes Emma better, and that we don't have the same ratings. Remember, ratings, just like utility, is ordinal. Only the order matters, okay? The cardinal or the magnitude doesn't matter. And that leads us to part C. Can you tell for sure whether I like Terminator 2 more than my wife did? No, not at all. Because the magnitudes don't matter. The only thing that matters is the order. You see, 8 is bigger than 5 and 5 is bigger than 4 in both of these individually. We can't say anything like, oh, I liked Terminator more than my wife did because 8 is higher than a 5. These are just movie ratings. It's just like indifference. It's just like utility. Utility is just orders, or like a ranking. You can kind of think about that. All right. So it says, often my wife and I argue about our rankings. True or false? It makes little sense for us to argue if we both rank one movie higher than the other, even if we assign very different numbers. True. It makes little sense. That's basically what I was just explaining here. All we know with rankings is that we ranked this one 5 over 4. We ranked Terminator as an 8 over a 5. We don't know who likes what more. It's just a rating scheme from a scale of 1 to 10 here, or utility is not within a specific number, but only the order matters. Okay, let's think about this mathematically now. So suppose that we're going to create two variables where x1 is the percentage of action time and x2 is strong women appearing on screen time. And so Terminator 1 has 80% action and it has 50% strong women on screen. Emma has, surprise, surprise, only 20% action and 40% of the time strong women are on screen. Okay, so now we're trying to put a little bit more mathematical on this ranking. Okay, so consider that I have a utility function that looks like this. Utility of x1 equals 10x1. And my wife has a utility function that looks like this. V of x2 is equal to 10x2. Notice I just changed this to V instead of U because U is for me, V is for my wife. We just didn't want to get confused. It means the same thing. Okay, well, if you look at the rankings here, actually, you'll see that I rank Terminator 0.8 times 10. Terminator gets a rating of an 8, and Emma, oops, I think Emma was supposed to be rated as a 2 over here. Emma is rated as a 2 over here, and I would rate Emma 10 times 0.2 as 2. So the ratings are the same. Look, my wife as well, 10 times x2. She only, oh, something I should point out, my wife only cares about what? x2. Notice x1 does not enter her utility function. She doesn't care about action. Me, on the other hand, all I care about is action. I don't care about strong women on screen. So my wife, she plugs these numbers into her utility function. Notice she ranks them as 5 and 4, just the same as she did. Okay, let's change those now. Let's say that instead of 10x1, I'm going to use some new utility function. I'll just call it u bar, is equal to 5.25 x1 to the 1/6 power. Does this do anything to the rankings? Okay, so remember, this is one of those positive monotonic transformations. If you think about what that graph looks like, it's just a graph that slowly goes up like that. So it's positive and it doesn't have any sort of curvature just more than one curvature. It just kind of slightly goes up like that. So in other words, that's going to change the number of the utility, but it's not going to actually change the order of anything, so it won't mess with my rankings. So if you were to check this out and you plug Terminator 0.8 into here, you get something that looks like about 5. If you plug Emma into there, you get something that looks about 4. So the reason why this is interesting is because using this function, I just transformed my preferences into something that looks like my wife's, because we still always agree that Terminator is better than Emma on both of them, and so I can, depending upon the formula I use to represent my utility, I can make it end up being, here it was 8 and 2, and here it's 5 and 4, because my wife and I intrinsically agree that Terminator is better than Emma. I can do anything I want to the numbers as long as the positive monotonic transformation. Anything that doesn't change the order of the utility, and it will still give me the same ranking. All right. Similarly, let's say my wife, now I'm on part C of part B, has a new one of, let's see here, V bar of 590. Oops. V of x2. Sorry, remember. She only cares about x2, is equal to 590 x2 to the 6.2. Oh, that's getting messy. Hang on a second. 590 x2 to the 6.2. Go ahead and plug x2, these x2 values, take 0.5 and plug it in there, and you'll notice that comes out to be about 8. If you plug 0.4 in there, that ends up coming about 2. What I've done is I make my wife's numbers reflect mine, because remember, the actual magnitudes don't matter, it's just the order. So I've showed you again, whoops, this is supposed to be an equal sign, how you can do any transformation from 10x2 to 590x2 to the 6.2. Notice this is a positive monotonic transformation. Once again, if you graph that, it looks kind of like this. You can do whatever you want to the utility, it doesn't change the order at all. And finally, suppose my wife had instead chosen the function, so suppose my wife actually chooses V underbar, I'm running out of letters here, 10 times 1 minus x2, does this change thing? Well, absolutely now, this will change it. Notice, this it's got a negative in front of the x2. In other words, more x2 is worse for her. This is the opposite of what we've been seeing it earlier. So what we've done is we've flipped her preferences the other direction, and we're saying instead of liking women, strong women on screen, she doesn't like strong women on screen. In other words, she likes it when there are no strong women on screen. Okay, and so basically, Terminator, if you plug these numbers in, Terminator 2 still comes out to be about a 5. But if you plug in Emma, it would come out with a 6, and that would go ahead and flip and make her like Emma more than Terminator 2, and that's because we flipped her whole preferences by putting the negative in front, so this part had better flip.